Hello and welcome to Marietta College's Geology 112 Historical Geology final project. This should be the last installment, and I'm going to try to walk you through the last part of the second week and then try to show you how you need to work on your project to write your final report. So the last thing that you should have done when you were turning in your material to Dr. Smith is finish your map. And I want you guys to have your maps out handy right now, and we're going to try to make sure that everything is correct with the map before we go on and start with the cross-section and then the petroleum geology and the geological history. So first things first, I want to show you the things that I've provided for you that have been provided on Moodle, and you should be able to access that and be able to print all of the material up for the class. They consist of a handout that walks you through the final part of the final project. They consist of a final lab report. It says lab manual as well in my version here, but you are not going to have to turn in your lab manual this year. That was something we had people to do last year, and I forgot to take that off right there. So you're only going to be turning in your final lab report. And then the third thing that we have is a template with which you should use, with which you should write your report. And it's basically a Word document, and it's an outline and some tables that you can enter the information in, and your report should be around 8 to 10 pages or so, including some of the documents like your map and your cross sections and your data tables that you'll be supplying. But you're going to be making recommendations about where there might be resources in the subsurface like oil and gas. Another thing that's going to be provided to you is the template for the cross-section. And the first part of our discussion right now, we're going to work our way to a point where we can actually, in a multimedia extravaganza, because I'm even using an overhead projector, we can figure out how to make that cross-section and fill it in. It's very simplistic as far as the skills that you've learned, but it should bring a lot of the things that we've been learning throughout the semester together, especially the work you've done recently in making your block diagrams with anticlines and synclines and using all of the symbols. That's going to be very important. Now, it should have been very important when you were making your map. So we're going to walk through the material that's listed here on the project outline. And in fact, the first 4A, 4B, and even 5 here are basically the same things that were on last week's lab. So there's a little bit of a repeat here in the material, but then you'll see with part 6, I've got a description of how to finish the cross section. So little by little, we're going to work our way through that. So let's first turn our attention to your map. And we would like you to pull your map out, and hopefully you did it in pencil because you will probably need to make some corrections on it. And it should look more like my map that you can see in your screen right now. This map is done correctly. It might be a little bit messy, but we're going to do our best. Now, what you'll notice is I have filled in the letters for each layer as well as the numbers that go with some of those letters. So every place where there's a layer that I can see, I made sure I listed that 6 and B, because layer 6 in your borehole is the same as layer B on the surface. So we want to make sure we understand all of those equivalents. So I've done that for every layer all the way across the map, and you should too. I've also written in the age, the time periods that each layer corresponds to, and I did it in several places on the map, wherever those layers crop out. And I also wrote in the information that has to do with the rock type that was there. So that's what we want to have on your map. The rock type, the age, the number, and the letter. As well as that, you'll see here's the Eocene coquina limestone. You also want to make sure you have the symbol that's appropriate for each layer showing the dip and the strike. Well, first things first, let's make sure we figure out where the anticlines and the synclines are. And through talking to most of you figured out fairly easily that this oval structure right here is an anticline. And the first thing you should do with that is draw a line down the middle of the anticline, which is basically the hinge line. And it should go all the way up to the top and all the way down to the bottom. Then put the symbol in the middle that indicates to a geologist that that structure is an anticline. So that's a double-headed arrow with the arrows pointing outward. And then, since this has sort of this wraparound where the contact actually makes an oval, it's a doubly plunging anticline, which you should have learned in your previous lab. And the symbol for a plunging anticline is a big honking arrow showing the direction of plunge. And since this one is plunging in both directions away from the center, you need to have one of those big arrows on either end showing that it's a doubly plunging anticline. For the structures that are out here, most of you noticed that as you go through the layers, you go B, C, D, E, and then back to D. So someplace in here, between this D and this D, we turned the dip around and created another structure. And there's a syncline right here. So I drew an axis or a hinge line right here for that syncline. And right in there I put the symbol for a syncline, which is a double-headed arrow with the two arrows pointing inward. It looks like a line with an X through it. Now I also did that over here on the other side of the map where I have repeat with E, F, and then E. So someplace in the middle of F is the hinge line for another syncline. And once you figured out that, of course, the F layer is Cretaceous, which is younger than the Jurassic, which is E, you said, oh, yeah, well, that's obvious. The youngest in the middle means a syncline. So F in this area has a syncline. Now I want you to draw your line and make sure your line stops right here where we go under the cliff for letter G9, which is the Eocene layer that's horizontal sitting above all of these folded rocks. That's how it should look. So, in essence, you should have those three structures with their hinge lines and the appropriate arrows. Since these synclines don't have that wraparound like you do with the ovals that are on the anticline, they're not plunging structures, so we don't need the extra plunge arrows on them. Then what you need to do is put in the strike and dip symbols. Remember, the strike symbol is a little dash that's parallel to the contact lines, and you could put 500 of them on your map for all I care. The more the better. But I put in enough so you could sort of see the trend of the dips in between where the structures are. And I want you guys to pay close attention to this one thing. On either side of the anticline, notice how the arrows for the anticline symbol are pointing away from the center of the structure, and that is similar with how the dip symbol on the strike points away from the center. So to the right of the hinge of the anticline, all of these dips point away. Now, we oftentimes get confusion at this point when people are saying, well, what should happen to that dip between the anticline and the syncline? And the answer is, well, it should stay the same until you get to the axis of the syncline. So all of these, think about it, all of these dip symbols should be pointing the same way. They don't turn around until you cross that syncline axis. So then you should have a few over there. And of course, the symbol for horizontal layers is that circle with the little plus sign in it. So if you want to pause this and look at that map for a while and make sure that your map looks similar to this, that would be the wise thing to do before we continue. Now, to continue with your final project, we need to make the cross-section for the subsurface area in Bullseye County. It's easier said than done, so we're going to walk you through this step by step. And be very careful as you're working through this. Don't get ahead of me, because I'm going to tell you some things that make sense only in hindsight after you've taught this project 20 times. So I'm going to tell you to follow along very carefully, and when I say do not do something, or do not do something in a certain way, or to do something in a certain way, please follow my instructions as well as you can. Of course, you should also do everything with a pencil. Now, I'm going to try to jump back and forth between working with these pieces of paper that I have magnetized to the board behind me. So you're going to have to bear with me a little bit. But please try to follow me step by step. I guess there is an advantage to the fact that we can actually pause this and you can try to do things to try to catch up with me. And I might start working on something, pause the filming, finish it, and then pop back on once I've done it so that I don't have to sit here for 20 or 30 minutes doing some nitty-gritty work. but you need to do it. So make sure you're following very closely. So you've been provided this cross-section that has some letters on it. It goes from J to Z, and what you will notice is that it has a little bit of a cliff face on it. Now, because of the way that we've been copying things and scanning things and trying to make things available to you and your home printer, when you print this up and the map up at your home, maybe not everything will be the right length, so it might not fit perfectly. So bear that in mind as we're going, and we'll be very forgiving when it comes to that when you're trying to hand in your final project and so forth. But keep in mind that this length, Z to J, might not fit exactly on the line on your map. Now, what we want to do is put a cross-section that represents the line from J to Z, going from sort of the northwest part of your map to the southwest part of your map. And so we could lay that down right there and start drawing away. Well, you need to know what to do. Now, follow my instructions very closely. If you look at your cross-section page, you'll notice that there's a cliff right here, and that corresponds to this line on the map that's separating layer G9 from the rest of the layers. And keep in mind, that's a layer that's sitting down on top of everything else that's been folded and has been bent into anticlines and synclines. It used to extend across the whole area, and there might have been thousands of feet of sediment on top of that as well. They've all been eroded away, so you can look at this cliff face as the erosional escarpment, and all the stuff across here's been eroded away. Sort of uncovered so we can see it. So we're going to pay attention to the stuff mainly below layer G9, but I'm going to show you how we can do that on the cross-section. The first thing I want you to do is take your cross-section page and do this. Fold it over so that you cannot see that layer G8. And so we're going to use it. Now, next thing I'm going to do might be very confusing, but unfold it. And you can see that we've made a nice crease along here. So we're going to solve a problem that might pop up a little bit later by taking that out of the equation, by basically taking a pen and pencil and drawing a line in there. Now this line is going to be the contact that is the base of G, and you want that line to go straight across and hit that 500-foot mark on your cross-section. So that's going to be very important. Now let's refer back to your lab material real quickly. So on your lab material on the first page, here are some careful instructions showing you how to take care of everything. The first thing I want you to do is look closely at the instructions here, and I've given you the tops for each layer that's present in the wellbore. Now, listen very closely. What I want you to do is I want you to, on your cross-section, you can see where the wellbore has been measured in, and along the wellbore, we've put a scale. Those scale has tick marks on it. Those tick marks are not the tops that are in your data. They are simply measurements every 500 feet going down the wellbore. So what you need to realize is that these numbers on your lab are different numbers than the scale on your piece of paper. So we want to put that information onto your wellbore. So the first thing I want you to do, well, listen closely, I want you to put the dash for each layer, like let's start with 0 at the very top. Layer 9G starts at 0 feet. That was the layer that they started drilling through at the very top of the cross-section. And what I want you guys to do is put 9G. But be very careful when you're doing this. Make sure you put the letter and the number below the little tick mark. Remember, what we're telling you is that that number is basically the top of the formation when it was first encountered as the well was drilling down through the layers. And that's what we usually record, is the tops of the formations as you drill well bores. For example, the next layer down, layer 8, the top of that is at 500. So I'm going to write the number 8, a little dash mark there at the 500, which is where I drew that line a second ago, because that's the top of layer 8. And I'm going to put the number 8 below that. So I'm going to slowly work my way down, and so layer 7 is at 750 feet, so that number would be right here, and then I'm going to put the number below. Remember, what I'm telling you is don't put the number next to the dash. Put it underneath, because we want the number to be within the layer that we're talking about. And since the number is at the top, that's where it has to be. So let's go down to the next one, 1700. Oops, I missed a little bit there. And that's the top of layer 7. Hey, is layer 7 the same as one of your letters? I think it is. It might be the same as F. So as you're going down and writing in those depths to the tops, and you're making sure that you're putting the number below the letter, or below the dash, also put in the letter. So that you have with layer 9G, there's 8D, 7C, 6B, 5A. And then of course 4, 3, 2, and 1 do not have corresponding samples on the surface that they had along with them. They're only present in the deeper parts of the wellbore. So make sure you go ahead and do those. And then you can pull that off of your map. Now the next thing I'm going to have you do is take your cross-section again and refold it so that the line at the top of the folded strata is basically going to be at the top of your piece of paper. And we're going to take this and very carefully lay it across your map. So J should be at the left-hand side, and Z should be pretty close to the right-hand side. Now, listen very carefully. As you put information on this map, I want you to put in every place that one of the contacts crosses the line J to Z. But do not put a dash in. I want you to put a little tiny dot on the line that you can see. And so, for example, I've already done it with the first one. There's already a dot on the line, and you can make it darker in there. But do not put a little dash. Do not put a dash coming down, because that will cause you problems later. I've taught this so many times that when people put a dash, they start drawing the next part of the line at the bottom of the dash. But I don't want you to do that. You'll understand that in a few minutes. But make sure you put in each of those tops. Some of you will want to go and put a whole bunch of dots in, but what you need to do while you're doing it is put in what the letter and the number are for each one of the layers. So do not go ahead and go straight across this, putting all sorts of dots in without recording what the number is for each layer. So put a dot in for each one. I guarantee that you will be forgetting by the time you pick it up. And if you pick it up and you walk away with this piece of paper, you're going to be saying, now where was that syncline axis, or where was that other thing? I don't know which is which. So this is what we do. We draw directly onto our section and we put in the numbers. And sometimes we have to flip this up a little bit. So that's 7C. And it would be good to make sure we put in the numbers too. Put in as much information as you can so that we're not, there wasn't a number with E, so that we're not having to flip back and forth, and that when we're done with our cross-section, we'll be able to do it quite quickly without a lot of painful scratching of our heads. So 6B, 5A, okay, I'm making my way across 6B, 7C, 8D, I got to remember to put the little dot in there. And then, E does not have a number that goes with it. And F. Now here, be very careful when we get to the cliff. We're not going to put the cliff in because the cliff is already there. I'm not going to pull this up because the cliff is actually in the wrong place on my cross section, but that's okay for now. What I'm going to do is I'm going to take this line right here, and there are a couple dashes here that I put onto mine to sort of show where the subcrop was for that layer. And then I'm going to try to imagine where, if we could peel up layer E, where this contact between layer 8D and E would come in and run into the map. So try to make yours look kind of like mine. So there's E, or there's F, there's E, there's D8. Hey, that jives with what's right here. And then the next one out would be 7C. So once you have that, now let's go back and look at where the anticline and syncline hinge lines are. And what I want you to do is put a little dash, now put a vertical dash where you have your hinge line, and then draw a line straight up and down across your entire structure, your cross section, all the way down to the bottom. It's going to be a vertical line. We're going to assume that these structures have straight hinge lines. That's not always the case in the world, but that's how it's going to be for our project. So what you should have is a piece of paper now that looks like this. It should have little dots across the top that have each one of the contacts between the layers. It should have labels about which layer is which, and then you should have vertical lines that are showing you where the hinge lines for the anticline and the two synclines are. Now, we're going to move to our Multimedia Extravaganza, and I'm going to point this thing at an overhead projector, and I'm going to finish the map along with you on the overhead projector, or the cross-section with you. Now we're going to have you finish your cross-section, and you're going to follow me very closely as we do this. Hopefully things don't shift. We'll watch where our dimetrodon ends up if I've been having trouble with my overhead projector. But we're going to try to do this. Now you can see the points at the very top where I put where the contacts are. Again, because of the Xeroxing and the scanning of these things, the scale of your cross-section and your map, I hope they're the same, but there might be a little bit of play in that. And again, we'll be forgiving with that. But what you've got so far should look pretty much what I've got up here. You can see the hinge lines of the syncline, an anticline, and a syncline. You can see the wellbore over here. You can see that I've got the depths to each one of the contacts, the tops of each layer that are down there. And we're going to try to make sure that when all is said and done, that the cross-section will honor the data that's in the wellbore as well as the data that we see on the surface. And there should be something, it might look kind of funny, but we're going to try to do it the best we can freehand, but still trying to be consistent. Now the first thing I'm going to do is I'm going to tell you that in the instructions tell you that the dips at the surface for all the formations that are not horizontal are going to be about 45 degrees. The question is, 45 degrees in which direction? Well, we know that this is a syncline right here, and we know that this is an anticline. So we should be able to figure out which direction the dip is at the surface in between each one of those structures. So if this is a syncline, the dips of the layers around it should be pointing inward, right? So dipping means the direction that it's going downward. So here's what I want you to do. Don't go and draw anything yet except for little dashes, and now I am going to tell you to make them little dashes at about 45 degree angles. So there's about a 45 degree angle coming down from that dot that you drew around the letter E. So everything on this side of that structural hinge should be dipping at about 45 degrees towards the structure. Now when we come over to this side of the structure, and we can see that layer right there, it's actually the top of 8D, this should be dipping in the opposite direction because we've crossed the hinge line of the syncline. And as we move our way across here, we should see that the dips should be similar, going through each one of those layers. And then we get to the hinge of the anticline. And then, of course, it should dip the opposite direction. So hopefully you can see this. I'm just putting little dashes in, and I hope my marker is not pooping out too much. Little by little, each one of those dips at about 45 degrees is coming in just like that. And I'm not drawing the whole line because I don't want anyone to, oh, here we got to the next hinge line. Of course, it's not beautiful, it's not perfectly pretty, but you can sort of see what I'm doing. I go to the other side of the hinge, and these dips should be going in the opposite direction. Okay? Now, here's where I can start to fill in the spaces between. And let's go to where we've got a syncline. It's easiest for you to see how to do it at those places. So for E, make sure you realize that the syncline is the place where the base of the bend should be. And you want to try to remain consistent with that. Now while you're doing this, I'm going to be real picky, and Frank is going to be real picky when he's grading. When we get down to the next layer, we want you to keep this layer the same thickness all the way across. That might be hard to do. So I'm going to draw the correct shape of that curve as we come down, and you can pay close attention to the fact that I'm maintaining the thickness of the layer all the way across the synclinal axis and then over back up to here. This is about the correct way to draw that. Now I'm going to put the incorrect way to draw it, and this is the way that some of you may have done it if you ran ahead. Some of you might have gone like this. Do you see how with the orange line I've actually made the formation very thick here, very thin here, and very thick here again? So you need to not do that. So that orange line is incorrect. That will be points deducted for your carefulness. So make sure that you try to keep those layers as consistent as possible going across. Now, when we get to the top of layer 6, I want to do the same thing there. Even though 6 goes off the page here, I'm going to try to maintain the thickness as much as I can. I might start to get a little chevron fold there, a little pointy fold, but that's okay. Our folds can have a little kinkiness to them. And then I'm going to go to 6B, and I'm going to continue that one all the way down to the syncline, trying to maintain freehand, the best I can, that thickness all the way across. Oh, but then we've gotten to 5A. Let's jump over to our other syncline, and let's fill that one in just like we did before, being careful to try to maintain the thickness of the layers all the way. Oh, I'm getting a little sloppy there. I want it to be just as thick as it was on the other side. Now here's where we're going to have a little trickiness, and I want you guys to pay close attention, because this, where it says 8D, this line is actually the top of 7C, and I want you to notice that the top of 7C is also over here, which means I actually need to move that top over a little bit so that I intersect that. This is where I want to make sure that I honor the data that's in the wellbore as well as the thing. But the confusing is that this line, even though it looks like I'm drawing it through that 8D, that's actually the top of 7C. And I want to bring it down across and through the wellbore. Now I fudged it a little bit right there because it probably has to do with the scaling of my different versions of my map and my cross section. So please, we'll be forgiving too, but you've got to have that line cut through the same dash that's the 7C on your cross section. And the same thing with the next line down too. Although it says, I'm starting here where it says 7C, it's actually the top of 6B. So this layer needs to come down across the synclinal axis. Oh, I'm getting sloppy there. I can do it quickly with this. Erase that. And then I need to make sure that that line's there. And look, oh, that's kind of nice. It actually hit right in the right place way over here too, where I had the top for 6B. Now the next one is the top for 5A. And I'm going to start it here, doing the same thing, trying to be consistent with the thickness. And I wasn't very consistent with the thickness there. Maybe I need to make that one a little bit wider. So I can do that. So I had to fudge that one. So that one is getting a little thicker over here. Now, what do we do below that? We have to fill in this area with the other layers. Well, how do we know how thick to make the layers that are below this? Well, we have information, and that information is over here on the wellbore. So when we want to draw bed 4, we just draw a line in here that's parallel to the layers above it. And we just try our best to remain consistent with the thicknesses of the layers across the cross section. So in the end, one layer at a time, you can fill this in and take those lines all the way off to the edge of the cross section and make sure that the lowest part of your dip is at the synclinal axis and the highest part of the arch is at the anticlinal axis. And again, it's okay if you guys end up having a little kinky chevron in here going across the map. So little by little, I'm going to finish my layers, and I'll end up with a structure that I can see is going across. I'm running out of space with my board. Oh, I just made it. Very good. So this is what your cross-section should look like somewhat when you're done. You should be able to see the synclines, the anticline, and the other syncline. Now what you have to do is go ahead and populate this with information. So this is layer 5A, and you tell me, what's the age of that? Right in here in big letters, Pennsylvanian. What's the rock type? I believe that's a quartz sandstone. Notice how it's at the anticline, and then it's exposed at the surface, just barely the very tippy top of that. The layer below it, what is this? That's the shale. That is the Silurian green shale. That's layer 4. Layer 3, layer 2, layer 1. Layer 3 is the Vuggy dolostone. And that is Ordovician. Layer 2 is the black shale. And that is Cambrian. 1, well, it's not a layer, it's basically basement rocks. It's granite and gneiss, and it's Precambrian. Then you can fill in all the rest of the layers by yourself on your own. But you need to have them all filled in and try to be consistent with labeling them. If you want to put labels over here too, so that you can be sure that you recognize which layer is which and what it's made of, so that you can quickly make some judgments. Now, you go ahead and do that, and I'll come back to you with some discussion about the final part of the project, where you're going to start answering questions about the oil and gas and the geological history, and that'll be getting you prepared to write your final project. One last installment so that we can try to finish our lab project right now. Now that you've finished the cross-section, you need to go through the lab material in the packet and make sure you answer all the questions. There should be enough information within the lab reading as well as within the questions themselves to help you answer each one of those questions. You should be able to figure out certain things about the geological history, and you can rely on your Grand Canyon lab to help you answer some of those questions, like when the laboratory asks what sorts of events happened during the formation of a nonconformity. Hey, you should have the answer already in your Grand Canyon lab, and maybe you can pull from that and put those steps into this lab. You might have to modify a few words here and there. So do your best in trying to answer all of the questions within the lab itself. Now, some of the discussion, once you get up to part 9, has to do with oil and gas accumulations. Now, I've discussed in my class a little bit some of the basics about that, but what you guys need to sort of think about for this project is the 4 main requirements for having an oil or gas accumulation within the subsurface. And those 4 things are source, seal, reservoir, and trap. Within your reading, I've supplied you with a basic discussion of each one of those things. If any one of those things is absent, then there's no oil and gas accumulation. You have to have all 4 things. And in the oil industry, we actually use these to try to come up with estimates of our high and low possible amounts of oil and gas in a prospect that we might be using. And these numbers are actually used within the economic evaluation to figure out the net present value of a potential exploration play. So these are important things. They are real to think about. But right now what we're just trying to get you to understand is some of the very basic concepts about the source, the seal, the trap, and the reservoir. So read through this. The few things that I will say, I could talk about this for about 4 or 5 hours nonstop. I'm not going to do that. So if you have questions and something's not clear, please contact me or contact Dr. Smith, and we'll try to help you along the way so that you can understand these important concepts. They're important especially to most of you guys, since you guys are mostly petroleum engineering majors. And this is what you're going to be doing for the rest of your career, and we work closely with geologists to try to understand what's going on in the subsurface. So the 4 important criteria that are used by the oil industry are the source, the reservoir, the trap, and the seal. I hope you can see some of the notes that I've written on the board. If you can't, I might have to move something up and down. I think that's probably okay. The first thing on the list is the source. The hydrocarbons that you're pulling out of the ground had to originally come from someplace. The source rock is a rock that is high in organic matter. Those include usually marine black shales that are deposited widely across the ocean floor, especially in areas where there's high productivity and a lot of upwelling that might produce a lot of the organic matter that gets deposited with the sediments. Not all shales have that organic matter in them. And then they have to be buried and then heated up a little bit in order to generate the hydrocarbons. So marine black shales, perhaps like layer 2 in the subsurface, that are generally quite dark in color. In fact, black shales are that good source rock. Just because it's black doesn't mean that it's a good source rock, though. We actually have to go through experimentation, rock eval, to actually see if it has organic matter in it. There are other reasons that a shale might be black. But the main source rocks for most hydrocarbon, especially oil plays, are marine black shales. Other possible source rocks could be things like coal beds, but it just so happens that coal beds are most likely to generate natural gas instead of oils. So we'll leave it there for the source rock. The next thing on my list is the reservoir. Once the source rock is heated and the hydrocarbons migrate away from that original source rock, they need to migrate into a body of rock that is porous and permeable. And so for conventional reservoirs, we generally consider types of sandstone and shale that have porosity and permeability to be good potential reservoirs. Those pores can be between the grains, such as an intergranular porosity, within the grains, such as intragranular porosity. They can be within old dissolved spaces where there used to be seashells or something like that, which would be called moldic porosity. And one thing that you guys should be familiar with for this lab is something called vuggy porosity, in which randomly shaped pores are dissolved within a limestone or a dolostone that create spaces where we might put oil and gas. And hint, hint, there might be a rock, number 3, that is a very good vuggy dolostone with lots of big pore spaces. In fact, I think in that rock you can see lots of oil staining also on those pore spaces. So I hope that you understood that when you were looking at those samples, that rock core sample number 3, I believe, is that very oily, vuggy dolostone that has lots of big pore spaces. Now, many of you have probably heard of a lot of other types of reservoirs that are called unconventional reservoirs, and those include things like coal bed methane, the black shale plays like the Marcellus Shale and the Utica Shale. Also, tight gas sands and tight gas shales are important reservoirs that just a few decades ago were not considered to be important oil and gas reservoirs. But today, with new fracking technology, of course, they can be accessed. But this play that we're talking about here is going to be more on the conventional side than the unconventional side. So those are 2 things. That's the source rock and the reservoir. The reservoir is like the tank where we're going to put the oil once it's been generated. Then you need a third thing, which is the trap. A trap is sort of hard to explain sometimes because it's more or less the 3-dimensional geometry that you're going to configure the layers into that might be able to entrap the oil or gas into an enclosed space. So it'll get stuck there and it can't migrate any farther. The fourth thing on the list is the seal. So you actually have to have within the trap mechanism, you have to have a layer that's in there that is impermeable, that's going to help the trap prevent any migration of the hydrocarbons any farther. So that's a lot of times something that gets confused with new people that are trying to understand these concepts, is that the trap and the seal are 2 different things. The trap is the 3-dimensional geometry, like a structural trap, which could be an anticline or a fault trap that makes a configuration where because of the immiscibility and the different densities of oil and water. It makes a place where the oil might rise above the water and get trapped against a barrier. The barrier could be whatever that seal is. So it could be a layer of shale or salt or gypsum that fluids can't penetrate. So if there's a layer of shale sitting right on top of a potential reservoir like a sandstone, and then you make a trap like an anticlinal trap, that might make a configuration where you can actually trap the oil and gas within that surface. Now what's even better is if the anticline is a doubly plunging anticline, in which it makes sort of that upside down canoe shape that you can trap lots of oil and gas in. And that's the type of trap that some of the biggest oil and gas fields in the world are. So, other types of traps include things like stratigraphic traps. A stratigraphic trap is a trap in which you might have something that grew naturally within an environment like a carbonate reef that might make a bump on the seafloor, and then if you deposit a whole bunch of shale on top of that, that would be a natural place that could be porous and permeable, where if fluids migrate into that reef, if it's covered with shale naturally, it can actually be a good reservoir. The same thing with things like river channels that might make little shoestring or isolated pods of sandstone that might be totally surrounded by shales. So, again, those are the four main things. The last two things I sort of mixed together a little bit, but you still have to think of them separately. So you need to have a source rock, such as black shale. You need to have a reservoir, such as a very porous sandstone or vuggy stone. Any rock with porosity and permeability can be your main reservoir. You need to have a trap, and I will give you a hint that this is a structural trap that we're looking for in this case. And so hopefully you've gotten enough information now. And then the fourth thing is within that configuration of that trap, especially potentially directly above the potential reservoir, there should be a impermeable layer like shale sitting on top of your potential reservoir within the anticline. All right, so you'll be asked to answer questions about what is the potential trap, what is the potential reservoir, what is the potential seal that's involved in this. So hopefully I've given you enough hints that you should be able to answer those questions. And again, if you have any questions about that and you find yourself unable to answer those questions, please contact us. So again, the last thing after you talk about a little bit about the petroleum geology, part 10 is describe the geological history of Bullseye County. And again, that's just like and very similar to the geological history of the Grand Canyon. So you can refer back to that. Make sure you just work your way carefully through that, and that's actually going to be part of your final project. So once you've finished, your final lab report, once you've finished doing this lab and answering all these questions, then you need to move on and write your final lab report. So that's the last thing on the list. And I'm going to put that down because consider that your lab experience is finishing up your cross-section and then answering the questions about the petroleum system and the geological history. And then you need to move on to the big report. Don't fret, because we've given you an outline for it, and that's present online. So before you panic anymore, make sure you've got at your disposal your map, your cross-section, your geological history, and you should be able to assemble your report fairly easily. It should be able to be put together. Now this is going to be due on this coming Friday, which I believe is the 24th. So make sure that you have it all turned into Frank by Friday the 24th of April. And also I want you to be aware that we're going to ask you to scan it or picture it or photograph it and send it to Frank, as well as uploading it on your Moodle into a Turnitin.com file. So you're going to have to do that in order so that we receive it. Again, this is due Friday by 5 o'clock. Now, again, don't worry too much because here's your report. We've made an outline of it, and we've actually given you the template. Within the template are tables that you'll have to fill in with the information from your lab, and you should also include the picture, or at least the map, and the cross-section, and you're going to discuss all of that stuff. Follow the instructions very carefully, and make sure if you have any questions, contact me or contact Frank, and we will try to work you through that information. Again, all of the instructions are here, and it should be fairly easy to fill in all the spaces, but we're going to ask you to make sure that you do it in a coherent way. In a report, make sure that you don't just draw pictures and just rely on the tables. You need to describe what's in the tables. You need to describe what's on the map. You need to describe what's on the cross-section. So in order to be able to go in and defend a decision about whether you're going to drill a well at position A or position G or someplace else on the map, you need to tell us why. And that's part of why we're having you go through this, so that you can understand what the basic parts of a hydrocarbon accumulation are. And here's a simple, even though it's sort of a fictional example, it is very similar to many other hydrocarbon projects that I've worked on in the past, similar rock ages and so forth. So make sure that you pay close attention to the instructions and work through this and be ready to hand it in on Friday to Frank. Thank you.